Okay, so continue with factoring. We're going to look at the special cases right now. This one should be pretty familiar to you. If A and B are real numbers, variables, or algebraic expressions, then A squared minus B squared comes from A plus B times A minus B. So earlier we were doing this one backwards. We were talking about conjugates and we were talking about the product of a sum and a difference. And we said that this ends up being A squared plus AB minus AB minus B squared, or just A squared minus B squared. But now we're using it to go backwards to do some factoring. So in other words, the difference of the squares of two terms whose factor, the difference of the squares of two terms factors into the product and sum of those terms. So let's go use that. We know if we see A squared minus B squared, and it has to be a difference, that comes from A plus B, A minus B. So we have a 36x squared and a 20 minus 25. So let me just rewrite that because 36 is just 6 squared and 25 is just 5 squared. So because both of these have the same power, we can rewrite that as 6x squared minus 5x. So we have A and we have B. So to factor this is just going to be 6 plus 5 times 6x minus 5. So like I said, this is a way that we can just quickly, without actually having to work our way through it. You can still use AC method on this. It's just going to take you a little bit more time to do. Sometimes being able to recognize that helps you out, especially if you go into pre-cal. It's used quite a bit sometimes. Factor of perfect square trinomials. If A and B are real numbers and variables are algebraic expressions, A squared plus 2AB plus B squared is equal to A plus B squared. So like I said, that was one we saw earlier as well. And then A squared minus 2AB plus B squared is equal to A minus B squared. So if we can recognize that we have something we can set up as A squared plus 2AB squared plus B squared, or A squared minus 2AB plus B squared, we know how to factor it. Once again, you can still use AC method or sometimes reverse FOIL on these. It's just helpful to know these patterns. But look at this one. Well, I can already tell you, I know I'm going to use A squared minus 2AB plus B squared, simply because we got that minus here. And that, if I can get it set up, we know it's just A minus B squared. So we square that binomial. Once then, 16 is just 4 squared. So we have 4 squared times x squared minus, we'll worry about this, but we see there's a 2 here. So let's see if we can pull out a 2. So if I do, we're going to have 2. Oh, sorry. Uh, my brain couldn't math there correctly. And I was like going like, oh, if I pull out the 2, then it's like 23. No, 28 plus 49 is 7 squared. So well, next time we go, like, well, this 28. Is this a 4 and a 7? Well, yeah, it is. So this is 4x squared minus 2. And we could break that up into a 4. 28 divided by 4 will leave me with a 7. So we see a squared, 2, and then we got our a because, oh, my disappeared, sorry. That would probably help. So there was an x there. That's I just dropped that off. So we can put that there. squared. Okay. So 4x is my A. We have 2, 4x, so that's my A. B is my 7. And we see that 7 here. So we have a squared minus 2ab plus b squared. If you do not see this right away, like I said, do not worry. You can still use a reverse FOIL or an AC method to help break these up. But now we know A is supposed to be my 4x and B is supposed to be my 7. According to this turns into A minus B, so 4x minus 7 squared. As I was saying, knowing these patterns is helpful later on. Oops. You also have a sum and difference of cubes. So this one, pretty much the only way you're going to factor a sum or difference of cubes is using this formula for the most part. Not saying there's other methods, but this is the most straightforward. So if I have an a cubed plus b cubed, that factors into a plus b. So plus here, a squared minus ab plus b squared. So this will stay plus, this will be minus. If I have a squared minus b, sorry, a cubed minus b cubed, that is a minus b, so minus is here, a squared plus ab plus b squared. So plus, plus, minus, minus. And then this one we see is the opposite sign. So if I have 125 x cubed minus 8, so 125 is just 5 cubed, and 8 is just 2 cubed. And once again, because it's the same power, cube, that's just 5x cubed minus 2 cubed. So what we had was that a cubed minus b cubed is a minus b, a plus ab plus b. If you don't believe me, that's a lot to remember. Right there. Oops, I forgot my cute squares. Good thing I did look at that. Square and square. So what we see here is that my A's are going to be the 5x and my B is going to be the 2. So this is just 5x minus 2, 5x squared, all of it is squared, plus 5x times B, which is the 2, plus B squared. So what we're going to end up with is 5x minus 2. This is going to be 25x squared plus 10x plus 4. So 125 cubed, x cubed, sorry, minus 8 would factor into 5x minus 2 times 25x squared plus 10x plus 4. So worksheet number 5, one example of each, a difference of squares, some sort of perfect square here, and then a sum of cubes. It may not have been very straightforward, but if you look at this one, think about it, that's y to the 4th, which is just y squared squared. And 49 we know is 7 squared. So we know that if I have an a squared minus a b squared, That is just going to be a plus b times a minus b. So what we see here is that my a is going to be that y squared. So we end up with y squared, and my b is the 7, so y squared plus 7, and then y squared minus 7. So this is common that you'll see something like y to the 4th, y to the 6th. You know you can break that down to something squared. It's just y squared squared. Here we have 9x squared plus 12x plus 4. So if you start breaking that down, well, that is just 3 squared, so that's 3x squared. This here, this 4 is just going to be 2 squared. And the 12 we can break down as 2 times 3x times 2. We have the a, 2 times a times b. And then we see the squares here. So write this one down again. If you have something that looks like a squared plus 2ab, got my 2 here, plus b squared, that was just a plus b squared. Too much written down here. A, B, B. My A's are going to be 3x, my B's are going to be 2. Well, this is just 3x plus 2 squared. Okay, so for C, let me just write over here. If I have a squared plus b squared, or cubed, a squared plus b squared cubed, that is going to be a plus b times a squared minus ab plus b squared. So what we have here is we got 27. So we have to think of what's the number cubed gives me 27. Well, that'd just be 3. 27 is 3 cubed, so this could just be 3z cubed. This is just 4 cubed. 4 times 4 is 16. Yep. And 64 would just be 4 cubed. So this is my A, and this is my B. So I would have 3z plus 4 times 3z, all that 3z's together, that's all my A, so that's all squared, minus 3z times my B, which is the 4, plus 4 squared. So we'll turn it into 3z plus 4 times, so 3 cubed is 9, so 9z squared minus 3 times 4, so that'd be minus 12z plus 16. Okay, so last bit here, special factoring techniques. For one more. Or so I could just go back over this. So a strategy for factoring polynomials, just going through everything that we have. First, look, see if you have a common factor that you can factor out. Then determine the number of terms in a polynomial and try factoring as following. If there are two terms, can the binomial be factored using one of these special forms? So is it a difference of squares? Is it a difference of cubes? Is it a sum of cubes? If you are left with 3 terms, then determine if you have a perfect square trinomial. So you have something that is an a squared plus 2ab plus b squared, or an a squared minus 2ab plus b squared. If it's not that, then use a reverse FOIL or an AC method to try to factor. And then lastly, if you have more than 3 terms, so usually it's going to be 4, then you might want to see if you can do a factor by grouping. we're going to go through. First step, do I have a D? Well, we have a 3, a 30, that's divisible by 3, and 75, that's divisible by 3. So all of them are divisible by 3. We have an x cubed, x squared, and an x. All of them are least divisible by x. So we do have a greatest common factor. So if I factor out that first, the first step is we just want to get rid of that greatest common factor if we can, because we're trying to factor completely. So if I do that, I'm just going to be left with 3x cubed divided by 3x is going to be x squared. 30x squared divided by 3x is minus 10x. And 75x divided by 3x is going to be 25. So we have a trinomial. So this is going to be a perfect square, but I'm not going to force you to do the perfect square on this one. You could just go back and go, okay, so looking at the trinomial part, A, B, C, I need two numbers, P and Q, that will give me 25, and that add give me negative 10. We're doing a reverse FOIL. Well, negative 5 times negative 5 would give me 25, and negative 5 plus negative 5 would give me negative 10. So the trinomial part that we had in red, that is just going to be x minus 5, x minus 5, which if we simplify that, it is just 3x, x minus 5 squared. So sometimes you'll just have to, like I said, maybe you have multiple steps of factoring. Sometimes because you missed something the first time, but also when you go through this, you might factor something and go, hey, I can factor that further. I factor out 3x, realize I have a trinomial. It's a trinomial that I can factor. And like I said, some of you may have looked at that and knew right away that it was a perfect square. If you didn't, you could still use reverse FOIL or AC method. Here we have y 6, 9y to the fourth plus 2y squared minus 18. Well, we have 4 terms, so we're going to use a grouping. So we're going to put y to the 6 minus 9y to the fourth, put them together in a group. And then we'll put the 2y squared minus 18 together in a group. So here I can factor out a y to the fourth. And I'll just be left with a y squared minus 9. Here I can factor out a 2, and I'm going to be left with y squared minus 9. So if I take out y squared minus 9, I'm going to be left with y to the fourth plus 2. So when you have binomials, we want to see, do I have a difference or a sum of cubes, which I don't? And then do I have a difference of squares? And yes, I do have a difference of squares. So if we take that difference of squares there, we have a y squared minus 9. So that is just going to be y squared minus 3 squared. And then we still have y to the fourth plus 2 still out here. So if I take this part and I factor it, a difference of squares, so a and b, that means it's just going to be y plus 3 times y minus 3. And then we still have y to the fourth plus 2. And now we're completely factored. I'm sorry, I didn't try to take out GC after the new. We didn't. That should have been my first step. But we didn't have one here. All right, so this will be our last problem for the section. You may have noticed in the notes there was a little additional section. After review, I've decided we're not going to cover that part. We don't need it. So this is going to be our last problem here. This is going to be 36x cubed plus 27x squared plus 30. Try to factor that completely. And then you have 2x to the fourth minus 2 and try to factor that completely. So this first one here, try to give us a little more room. So I'm going to put a over here again. So 36x cubed plus 27x squared plus 30. So what we can factor out, and I think there's supposed to be an x here. I think I got missed. Should be an x. I'll go back and fix that. So 36x cubed plus 27x squared plus 30x. So we can divide everything by just 3? Yes. So we divide everything by 3. Yeah. Actually, I think we could divide everything by 9. No, we can't. I don't know why, for some reason I thought we had a 9 there. So no, we can divide everything by 3, and we can divide everything by at least an x. So we can take out a greatest common factor. So 36 divided by 3 would leave me with 12. And then we have an x cubed divided by that x, so we have an x squared. 27 divided by 3 is 9. X squared, if we divide out the x, leaves me with x. 30, if we divide by 3, leaves me with 10. And then we have no x left behind. So the next part of this is we want to try to see if we can factor this part further. So I'm pretty sure it's not a perfect square. So we'll have to use an AC method. So my A times C would be the 12 times 10, which is 112. So we need two numbers whose product is 112. That would sum up to 9. So try to think of some things here. You could just try 12 and 10 right away because we already know those are going to, we already have those factors, but we can see instantly that's not going to work. So other options that I might have. Oops, that's not that one. We do have 8 and 15. Those multiply to give me 120, but once again, when we add those together, we're going to get 13. So what else can we try? Oh, we can try 6 and 20. So 6 and 20, that's going to give me 26. That doesn't seem to work either. Okay, so just a second. I'm going to put down my list here so you don't watch me do all of it. Okay, so once through, this is everything that could possibly work. 12 times 10, well, that doesn't add up to 9. 8 times 15, that doesn't add up to 9. 6 times 20, as you see, these are all the pairs that would give me a positive 120, and they could add to a potential positive number, so a 9. So I didn't look at my negative factors because I only had to look at positive. So what we see here is that this is actually prime. So the only factoring I actually would do is just 3x is equal to 12x squared plus 9x plus 10. So sometimes you might look and you can't actually factor any further. Now, with b, we instantly see we can factor out a 2 from both numbers, and we're going to be left with an x to the fourth minus 2. Oops, minus 1. Well, we have a square and a square because x squared squared would give me x to the fourth, and 1 is technically 1 squared. So we do have a difference of squares. So this is 2 x squared plus 1 times x squared minus 1. Always worth looking that when you start to factor that you might think you factored everything. You want to go back and check, and sometimes, like I said, you'll think that maybe this should factor further, and it doesn't. It's just things to look for. But always make sure that you cannot factor further because sometimes you in fact can't, and sometimes you have to keep factoring.